Let us know some factors which are mainly influencing the hardened strength of the concrete or strength of the hardened concrete. In that, the first and foremost, what I am considering is a water cement ratio. In the general view, it will be considered as water to binder ratio. In our case, the binder is cement, so I am taking it as water cement ratio. So you know about this. If the water content is more in our concrete, it will be good in workability. If the workability is more, then it is going to place easily and compact easily, finished easily. But in the other side, there is an disadvantage. The more quantity of the water which will be left as it is in the concrete upon hydration, it is going to be evaporated from the place, then leaving that place as empty. So we are discussing about the water cement ratio. Here, way balance is indicating the thing properly, I guess, where the cement is in one side and water is in another side, which is completely balanced properly. So our whatever the concrete is resulting will be attaining good compressive strength. So it is indicated by this sketch. And in the other hand, if we have the more water content and lesser cement content, which is imbalanced, and there is the availability of the excess water, so our concrete is become weak and it has a lesser compressive strength. And the loss of compressive strength is because of the loss of compressive strength is mainly because of the pore content which is going to be formed upon evaporation of the water from the concrete. The excess water is there because of the more water cement ratio. Okay, so generally when we are talking about the workability, we need more water content, but when we are talking about the strength, we need lesser water content. So in the general cases, when we are doing the concreting, we will follow the water cement ratio varied from zero point 0.4 to zero point 0.6. Okay, if the water content is zero point 0.4, we'll attain more compressive strength. If the water cement ratio is zero point 0.6, then it will attain a lesser compressive strength. But for high performance concrete or high strength concrete, we will go for the water cement ratio as less as zero point 0.4. So in this condition, workability will be less. For that, we are going to add the admixtures. So with this, finally we can say the water content should be less to have the more stiffen and more strength of the concrete. Here what I am indicating is the achievement of the compressive strength over the water cement ratio, increment or decrement. If the water cement ratio increases, automatically the compressive strength will keep on decrease. This is because the availability of the more pores because of the evaporation of the excess water which is left as it is in the hydrated mass. So if the lesser the water content at this stage, the compressive strength will be more, and if the water content is more, so water cement ratio is more, the compressive strength will be less. So this is indicated by this graph, and here you can see the relation. It is not an linear relation. It is something like in parabolic in nature, but it is almost indicating the similarity of the linear relation. In some cases, we are going to indicate the water cement ratio with respect to the compressive strength as the exponentially increasing or decreasing curve with respect to the increment or decrement. Here one more thing you know, like noticed the two curves with respect to the compaction. If I am doing the hand compaction, even with the water cement ratio with the lesser condition, it is going to attain the lesser compressive strength as compared to the vibration. So it matters that water cement ratio is an important aspect in the achievement of the compressive strength. So to have the more compressive strength, we should be with the lesser water content, but it will affect the workability, that is to be balanced by using some kind of admixtures. Ferret and Duff Abraham explained something about the relation between the water as well as cement paste formation. Ferret explained about the attainment of the strength of the concrete by the plasticity law. He explained with the some equation where S is equals to K of C divided by C plus W plus A plus whole square, where C is the volume of cement, W is the volume of water, A is the volume of air, and K is some constant by Ferret. Duff Abraham's law, according to that, the plasticity of a mixture will attain the strength, concrete is going to attain the strength when it is being used with the proper quantity of water for a bag of cement. So, based on that, he had given an equation S is equals to A divided by B to the power X, where S is nothing but the compressive strength which is going to be attained at 28 days, and A is the surface area and B is the 7 and X is nothing but water cement ratio. According to this, it is going to indicate the complete plasticity law of the concrete. From all these things, we can conclude that if the water content is more or the water cement ratio is more, strength will be less, and water cement ratio is less, automatically strength will be more. But to attain more strength in the high performance and high strength concrete, we will go for the lesser water content, and we are going to tackle the problem of like improper consistency and lesser workability problems by using the admixtures. The gel space ratio is indicating the availability of the empty space for the formation of the hydrated mass of the cement. So it is considered as the ratio by taking the volume of the hydrated cement to the volume of the sum of like volume of the hydrated cement as well as the volume of the pores. That means the total volume which is available for the formation of the gel to the volume of the gel formed. These two things are indicating the space ratios or the volume ratios just to form the gel. Okay, so if the gel space ratio is more or the availability of the space for the formation of the gel is more, so it is going to get the more quantity of the hydrated cement and then it is going to achieve more strength.
In general, the strength at any water-cement ratio is a function of degree of hydration of a cement and its physical and chemical properties, temperature at which hydration takes place, formation of cracks due to bleeding and shrinkage, air content in case of air-entrained concrete, change in the water-cement ratio. With these, some of the researchers stated that the strength of concrete can be related to the hydration products, that is gel space ratio. Gel space ratio is defined as the ratio of volume of hydrated cement paste to the sum of the volumes of the hydrated cement and that of the capillary pores. A relationship between the strength of concrete and gel space ratio is established by Power and Brownyard. A typical curve relating gel space ratio to the compressive strength is displayed. The strength of concrete considering gel space ratio is calculated by S is equal to 240 x cube, where S is the strength of concrete, X is the gel space ratio, and 240 is the intrinsic strength of gel in Newton per millimeter square for the type of cement and specimen used. Calculation of gel space ratio. For complete hydration, let C is the weight of cement in grams, and W0 is the volume of mixing water in ml. Assuming 1 meter L of cement on hydration produces 2.06 meters L of gel, then, volume of gel, and space available is expressed as. Finally, gel space ratio equation becomes. For partial hydration, let alpha is the fraction of cement that has hydrated. Then, volume of gel, and space available is expressed as. Finally, gel space ratio equation becomes. The limitation of this theory is that the theoretical strength of concrete is much more than the actual strength of concrete.
So, from this, we can get the idea. If the gel space ratio is more, then automatically the strength of the concrete will be more. The reason for this is when the more space is available for the formation of the gel, it is having the more quantity of the hydrated paste will be formed. And in that limit, if we have, say for example, so more space is there, so and it is having the problem of empty pockets in the hardened concrete, does those things will come into the picture, or something it is the space available is beyond the requirement of the paste formation, then it will cause us the problem. Okay, so the space required should be, it is matching with the paste formation in the concrete. So if it is balanced, then only it will give the strength. Say when I said when the gel space ratio is more, then automatically your concrete bond strength will be more. Then we are going to give the more space, then we will get the good quantity of paste, so we can have the more strength. No, it won't come into the idea, because whatever the quantity of the paste is going to form, the hydrated paste, for that only the required space should be there. If it is congested, then it will lack in the formation of binding and then reduction of the strength. If it is sufficient, then it will be giving the good strength. And if it is more space is there but the formation of the gel is less, then again it is going to give the lacuna, or it is going to reduce the strength. And in the powers graph, it is taken like gel space ratio along x-axis and strength along y-axis for the different mixed proportions. As the gel space ratio increases, it is going to increase the compressive strength of the cubes at 28 days. Okay, so even though the proportion is different, they are indicating the increment of the strength with the increase of the gel space ratio. So if the gel space ratio is more, automatically the compressive strength will be more. As we all know, the strength of the concrete will be achieved as day by day gone after the adding of water. Then what are all the factors or the things will influence the strength gaining of this concrete? Is it maybe the time? Say for example, if I'm adding the water to the concrete today, so after 28 days it is going to reach some strength, or as the time goes it is gaining the strength. Is it only the thing will affects or causes the gain of the strength? No, there is one more point, as the heat of hydration rate increases, the rate of gain of strength will also increases. Already we have learned about it. In this, what we are doing or looking at this is, As the time goes, similarly as the temperature of the concrete is to be maintained as usual, then automatically the rate of hydration will keeps its actual rate of forming the paste, so that our strength is going to attain at the particular time. In the general, what we are saying, at the 28 days we will get the strength, at the 28 days we will get the strength. That is because we are going to do the curing by maintaining the temperature of the concrete in an average around 18 degrees Celsius. With that, we say that it is going to attain the strength at 28 days. If it is not, then what will happen? If it is not, as the days goes, concrete is not going to gain the strength even it is at the lower temperature. Say if your concrete is at Kashmir, there the atmospheric temperature is very low, then automatically there might be the lesser rate of hydration, so we are using the rapid hardening concrete cement over there, okay, to get the concrete hardened within the particular stipulated time. That is because the rate of hydration is less. So you can come to the point now, not only the days but also the temperature of the concrete, which is helping the hydration of the cement paste, is also an important thing. And this is being explained in my topic, the maturity of concrete. Maturity of the concrete is nothing but summation of the product of your temperature of the concrete in an average of the day into that of the time taken. Say if I want to calculate the maturity of the concrete at the particular 7 days of time, what I will do to calculate the maturity, I am going to do the product of 7 days into 24 hours and multiplied by the average temperature of the concrete for 1 day. So that will give the some value. That value I am calling it as a maturity, and it will be measured as degree Celsius R, because I have taken the multiplication of the temperature that is being expressed as degree Celsius and the time that is in terms of hours I have taken. Even some of the cases we will use degree Celsius days also. Okay. Then how do we measure the temperature, and how do we take the time, and how do we calculate the maturity? Let us see. See, if I am curing the concrete by keeping it in the pond curing, and I am maintaining the temperature of the concrete around 18 degrees Celsius complete throughout the day as an average. Okay, so it may be varied with respect to the increment or decrement of the atmospheric temperature, but I am keeping it checked for 3 times per day, and then I am taking it as average, and I am taking the average temperature what I have maintained in terms of degree Celsius, and that is being multiplied by the time how much it has been taken from after adding of the concrete. Say if it is completed 24 hours, then I will do the maturity calculation by just taking 24 into the average temperature maintained in that time. Sir, if I am taking 7 days, if it is the temperature is day by day, it is varied. Even the average of the day by day is varied. How to calculate? First, what I will do is I will take the average of the 1 day temperature, and then I will take the average of the 7 days temperature, and that average value is again multiplied with the time. So we are getting the maturity value in terms of degree Celsius or degree Celsius days. Okay. Hydration of cement paste will start only when the concrete is having the temperature around minus 11 degrees Celsius. If it is less than that, or if it is minus 14 degree, or if it is 15 degree the temperature, then the hydration will not start at all. So there is no any gain of strength in our concrete. For that purpose only, in the calculation of maturity, we will take minus 11 degrees Celsius as the datum for the calculation. Okay, in the problems we will come to know about this. Let us see. If you are curing the concrete for 28 days, at an average temperature of 18 degrees Celsius, its maturity will be 19,488 degrees centigrade R, and it will be approximately taken as 19,800 degrees centigrade R, because the hydration of the concrete will starts at minus 11 degrees centigrade, and so it is taken as the approximate value 19,800 degrees centigrade R at the 28 days of curing. This is mainly because the accurate value is calculated by dividing the time into smaller intervals and observing the some temperature variations. Because of that, we are doing it as the approximate value of 19,800 degrees centigrade R. This Plowman's equation is used to calculate the percentage of strength achievement at the particular days of the concrete. Say I want to know what is the achievement of strength at my 7 days of the concreting. If I want to know, then we are using this equation where it is given as 19,800 degrees Celsius R, where it is representing our approximate value of the maturity at 18 degrees Celsius curing for the 28 days of time. So that value we are taken as 19,800 degrees Celsius R. Okay, and which is equals to A plus B log 10 maturity divided by 1000, where A and B values are taken based on the strength of the concrete at 28 days to be achieved. Say for example, if I want to achieve the strength of 20 MPa at my 28 days of curing, so it is coming in this line. So my A value will be 21, B value will be 61 to be substituted in this equation. Okay, say if I am having the 40 MPa achievement of the strength, then I have to take the second line where my A value will be 32, B value will be 54, that is to be substituted in this equation. So based on the strength achievement, we are taking the A and B values. And the maturity, you know how to calculate, previously you know about it. By substituting in this, we will get the percentage of strength achievement at the particular time or days. Say for example, it is 7 or 14 or 20, whatever the day you want, for that you can calculate. Okay. Let us see how to calculate the maturity of the concrete. Through that, how to assess the strength of the concrete at the particular time. Here I am explaining a problem so that you can understand what is the maturity and how it will imparts to calculate the strength of the concrete at the required time. Example 1, the strength of the sample of fully matured concrete is found to be 40 MPa. Find the strength of identical concrete at the age of 7 days when cured at an average temperature during the daytime at 20 degrees Celsius, at night time 20 degrees Celsius. Here they are asking what is the strength of the concrete at 7 days of time if it has to be gained at 40 MPa after 28 days of curing. That means at 7 days how much strength it is going to gain it. Let me think how to use this value, or what is the necessity of calculating 7 days strength. Because in the site, if we want to unstrip the formworks, we need to satisfy with the particular stress bearing capacity of the concrete structures. If it has attained that value, then we can remove the formworks. Based on that only, we are scheduling the dates for removal of the formworks. For that, we should know what is the strength attainment at the particular days of time, so that we can calculate the strength at the particular days using this maturity value. From that, we can have the idea when we can remove the formwork. For that, it will be used. Let me look at this problem. Here they are looking for the problem, like to calculate the strength at 7 days. So first what I am doing is calculating maturity of the concrete at 7 days. What is maturity? It is nothing but the the calculation of the maturity is done by taking the product of time into the temperature. So here the time is 7 days, but temperature is two are there. One is at the daytime and other is at the night time. Two different temperatures we have. So I am calculating separately for both of them. For 7 days, the daytime will be taken as 12 hours, night time will be taken as 12 hours. And the temperature average was 20 degrees Celsius and night it will be 10 degrees Celsius. So when we are calculating the temperature, the minus 11 is being taken into the account. This is because hydration of the cement paste will be initiated even the concrete temperature is minus 11 degrees Celsius. So it has taken as the datum. Because if the temperature is less than this minus 11 degrees Celsius, say for example, if it is minus 12 degrees Celsius, our hydration of the cement paste will not start. That's what we are using this as the datum. Okay, so at 11 degrees Celsius, that is minus 11 degrees Celsius, only the hydration of the cement paste will start. So we are taking. So to know the temperature given for hydration of the cement, if I have started the hydration at minus 11 degrees Celsius and I have reached 20 degrees Celsius, total temperature should be taken from the datum to till the end point. That's what we are taking the sum of 11 as well as 20. We are getting 31. Okay, and the other side also 10 degrees Celsius means it will be taken as 21. Okay, this is because of the initiation of the hydration of cement paste will starts at minus 11 degrees Celsius itself. Okay, and next is and it will be constant for all the types of problems to calculate the maturity. And next is just taking the sum of these two products, that will give the maturity value of that concrete of 40 MPa at 7 days. Then how to calculate the strength using this? That is, we are doing the calculation by using the Plowman's formula, where maturity equals A plus B log 10 maturity value divided by 1000. Using this we are calculating. Using the 66.5% of the strength achievement, I am calculating the strength of 7 days for my 40 MPa concrete. Will be using that percentage, it will be 26.5 MPa strength. So it concludes that at 7 days the concrete will gain 26.5 MPa of strength. And let us see about the next problem. Here the laboratory experiment conducted at site, they have given a place as Pune, on particular mix showed a strength of 32.5 MPa for fully matured concrete. Find whether former can be removed for an identical concrete placed at Srinagar at the age 5 days when the average temperature is 5 degrees Celsius and its pressure or the stress of the former is limited to 25 MPa. So here they are mentioning in Pune they have used some proportion of the concrete and it is going to get the 32.5 MPa strength after complete maturity. Okay, if the same proportion, same concrete is used in Srinagar and the days, what was it has taken as 15 days and average temperature at that place for 15 days was 5 degrees Celsius. Does we can remove the formwork if the allowable stress in the removal of formwork is 25 MPa. That means your concrete had attained at the 25 to 15 days, it had attained the stress more than this, then you can remove the formwork, or else it is not possible to remove it. Okay, so we are going to check whether it is possible to remove or not. Okay, let us see the calculation of maturity. Through that we are going to calculate the strength. So at the 28 days, concrete is going to gain 32.5 MPa of strength. And now the same proportion is used at Srinagar, and it is at the time of 15 days. And average temperature was maintained as 5 degrees Celsius. So the maturity will be calculated as time in days and taken into the hours, then multiplied by the temperature. Okay, here you can see or notice, again we are taking minus 11, because at minus 11 degrees Celsius itself our concrete will starts to form the paste, and it will starts to hydrate, and it will starts to gain the strength. Okay, that's what we have taken as the datum, and then we are adding it to our 5 degrees Celsius. Okay, from this we are getting the value 15 into 24 into 16, so that it will be 5760 degrees Celsius R. So the concrete is coming in the that 2.5 MPa will be in second zone of the table what we have shown in the previous, and there A value will be 21, B value will be 61. Okay, using these two values, and remember these values are taken from the table what we have shown in this previous video. Okay, and using this A and B value we are calculating the percentage strength which will be gained in 15 days. Okay, and next let us see about the equation A plus B log 10 maturity divided by 1000. So A value will be 21, B value will be 61, and maturity will be 5760 and divided by 1000. So it will be 21 plus 61 log 5.760. So from this 21 plus 61 into log 5.760 is nothing but 0.7604. So it will be getting 67.38. It will be in terms of percentage. Remember, it will be in terms of percentage. So at 15 days, and the concrete with the attainment about 32.5 MPa will be getting the strength of 21.9 MPa. So in 15 days of curing, our concrete will get 21.9 MPa. But for the removal of the formworks, it requires 25 MPa of strength, which is again greater as compared to this. So strength is not at all achieved. So we can't remove the formwork. Remember, it is not possible to remove the formwork at 15 days. We have to wait for some more days, so that it has to more than this 25 MPa, then we can remove this.